Right after the discovery of X-rays and radioactivity, there was a real craze for using these new technologies. Beauty products, chocolates, cigarettes, medicinal waters, and even suppositories were manufactured with radioactive substances. In medicine, X-rays began to be used indiscriminately. Doctors would take radiographs of patients' heads without proper control, which led to effects like hair loss weeks after the exam. The big problem was the lack of exposure limits. At that time, no one knew what amount of radiation the human body could safely handle. Over time, it became clear that ionizing radiation, although extremely useful, could cause serious harm if misused. Today, it is applied safely in diagnostic exams, cancer treatment, nuclear reactors, and even in dating ancient materials. But why is ionizing radiation dangerous? Radiation is, simply put, energy in motion, and it can travel through a vacuum, air, or materials. It can appear as particles, protons, neutrons, electrons, or as electromagnetic waves, like visible light, X-rays, and gamma rays. When we talk about risks, we specifically refer to ionizing radiation, which has enough energy to knock electrons out of atoms, a process called ionization. The amount of energy needed to ionize depends on each chemical element. In the case of the atoms that make up the human body, hydrogen, oxygen, carbon, nitrogen, only high-energy radiation, like X-rays and gamma rays, can do this. That's why radioactive materials or intense radiation sources must be handled with extreme care. Unstable nuclei, called radioactive, emit radiation in search of stability. This emission can occur in three main forms. Alpha particles, helium nuclei without electrons, easily blocked by a sheet of paper. Beta particles, emitted electrons, which can pass through paper but are stopped by wood or aluminum. Gamma radiation, high-energy electromagnetic waves that can penetrate several centimeters of concrete. Despite the differences, all these types of ionizing radiation cause the same fundamental effect, removing electrons from atoms. This is dangerous because it can break essential chemical bonds in molecules in the body. When it occurs in DNA, it can cause mutations, cell death, or even cancer. Radiation can act directly, hitting DNA and breaking its chemical bonds, or indirectly, interacting first with the body's water and forming highly reactive free radicals that then attack DNA and other molecules. Although DNA has repair mechanisms, they are not always sufficient. There are two main types of effects. Tissue effects occur when a large number of cells die. They can appear immediately after high doses, like burns, hair loss, inflammation, or later, like cataracts. This type of effect only occurs when the dose exceeds a certain limit. Stochastic effects, related to DNA mutations. The most well-known example is cancer. Unlike tissue effects, there is no minimum dose. Any amount of radiation increases the probability, although the risk from small doses is low. Stochastic effects can take years or even decades to appear. Acute radiation syndrome occurs when the whole body receives a very high dose in a short time. Symptoms range from nausea and diarrhea to severe infections, bleeding, sterility, and, in extreme cases, death within days. Most of what we know about radiation effects comes from historical accidents and tragedies, such as Hiroshima, Nagasaki, and Chernobyl. Survivors of these exposures helped science understand both immediate and long-term effects. Studies clearly showed the relationship between high doses and cancer, but to this day, there is no conclusive evidence of hereditary effects in humans, although such effects have been observed in animals and plants. Today, knowledge of radiation safety is much greater than at the beginning of the 20th century. Radiation remains a valuable resource, especially in medicine, where it can save lives in diagnosis and treatment, as long as it is used in a controlled and responsible way. Thank you for watching. I hope this video helped you understand ionizing radiation, its history, effects on the human body, and its modern applications. Remember, radiation can be dangerous if misused, but when applied safely, it's an incredibly powerful tool in medicine, science, and industry. If you enjoyed this video, don't forget to like, comment, and subscribe for more science explained in simple and interesting ways. See you in the next video.